So this A is the same as that A, but then inside here, I'm gonna have X minus a quantity H, and that could look like a plus, but we write it as minus for good reason, plus K. So one of the things we're going to talk about is how to take that and turn it into this, and we can do that with some easy algebra. We just got to be careful. And then once I've got it in this form, this tells me some really good stuff. So the vertex, the tip of the parabola, is at the point HK. So immediately I find that. If I just take this, do this algebra to get to here, I know what the vertex is. And if A is positive, the parabola opens up. If A is negative, the parabola opens down. If A is 0, we don't have a parabola. We have a line, so we wouldn't have to worry about it. Alrighty, so let's start with a nice example. Let's actually make a little plot here. Let's see here. So it's H, K, I put that. And then from here, I don't know if it's this or if it's this. And it depends on what A is. So that looks pretty weird. Like this. Alrighty, so example 1. Maybe the problem says graph y equals, and let's start off pretty chill, x squared plus 5x. Let's see, that's gonna be, ooh, let's not start out with a 5 there. I'm sorry, I got a little too excited on that. And let's put a 10. There we go. We'll start out super chill. So the main technique we need here is completing the square. Does that sound vaguely familiar? Sure? Yeah, okay. Yeah, okay. Oh, good. So now there's something new to be learned here for some. That's fantastic. So we're going to complete, let me show you how to do this, the square. And the goal is to create this thing. We want to figure out what that piece is and what's left over on the outside. So step 1 is group the x squared and x term together and leave a little space. So this is going to become y equals, I'm going to put a parenthesis, x squared plus 6x, leave a little space, plus 10. So that's what I mean by group them together. Really not much has happened. Lighting okay? Let me pull a little front light on here. There we go, a little better. Everything cool? Yeah. All right, so step 1 is this. Step 2 is take 1/2 the x coefficient. So that's the number in front of the x. So here we have 1/2 of 6, that's going to be 3. And square that and add it on. So comma, square it and add it on. Add it inside the parentheses. And also subtract it outside the parentheses. We don't want to start tossing stuff in because then we'll change everything and it won't be the same thing we started with. Also subtract it outside the parens. So in here, we're going to get 3 squared. When I took that, half that 6. And so I just add 3 squared. And I'm going to leave it just written like that. And I'm going to subtract it out here. We'll do a couple. And this is kind of the easiest case. When there's a number in front of the x squared, we got to tweak it a little bit, but it's pretty straightforward. Why did we do that? We did that because now we have a perfect square inside the parenthesis. So whatever you got here, when you took half that, that's the thing that we squared, but it's also the thing that I add on to x inside the parentheses with the square. So then contract back to a square, or contract to a square. And what I mean by that is we're going to have something x plus or minus blah, blah, blah squared. But this thing here, this is just the half of the x coefficient. I just add it here. If it was negative, I'd be subtracting. So you've already done all this work. And then I have to, what do I have on the outside? I've got plus 10 minus 9, so plus 1. In effect, just kind of chill it out. We're going to go a little bit. So simplifying, get y equals x plus 3 quantity squared plus 1. So let me stop. Check that out and make sure that you see, and you can, let's just check it real quick. X plus 3 times x plus 3 plus 1. Just to show you we have the same thing. I would FOIL first, outer, inner, and last, and then I still have the plus 1. So I get back what I started with. Cool. Yes, sir.
So from this side to where we got up here to where it was originally just y equals, in parentheses, x plus 3 squared.
Yeah.
Are we dropping that 6x from like?
So that
In
is
terms
the,
of like not worrying about it from that point?
yeah, essentially, yeah. We're hiding it inside this notation
Okay.
now. Because notice here, Mace, that if I took x plus 3 and squared it out,
You'd get the same thing.
you get the 6x back. So
Sure.
it's just hidden inside
Okay,
there now.
okay.
Yeah. Thanks for caring. Makes me happy. I appreciate questions.
I'd rather understand than not.
I would rather that too. I like it. There's like something about being here to learn shit that makes that seem right. Okay, so let's see. I'll just erase this. Good stuff. So compare this to now. You'll do this automatically in the future, but compare this to the a plus h squared. Did I have I have minus there, plus k. And so I'm just gonna write it underneath y equals a x plus 3 squared plus 1. So what is my h?
3
Is
squared.
So notice we have a negative 3. So the thing that you're subtracting off here is negative 3. It's always going to be the opposite of this. So here h equals negative 3. And that's the only subtlety. And then k is 1. So my vertex of that parabola is at minus 3, 1. Does it open up, or, oh wait, I just had a 1 here, sorry. I wrote a there, but there's a 1 right in front. This thing opens up, because I've got a positive number in front of that square. I got a positive number in front of the x squared. So this thing just goes like this, and that's a pretty crappy drawing of it, but it gets the feeling. Let me stop for a second, because I want to say something about this after I fix it. I can't stand looking at that. That's better. So notice that this is the point minus 3, 1. That function that we started with, it's not up here anymore, it's pretty close. This function has a minimum value. So in terms of the output, there is a minimum value. And this is going to become very important for us for calculus. So a minimum value of 1. So when I talk about minimum values, we're going to talk about two things. What is that output and where does it occur? At x equals negative 3. Yes.
sorry for it
Oh,
being
please,
slow if I
please ask.
missed this, but how do we determine? I remember, like I have the note saying if A is greater, it's facing upwards, and if it's lower, facing downwards. How do we get that from there?
So just look, if there's a positive number in front of the x squared or here,
Okay.
then that's a positive A. So you can go back, Mace, to the original, it was this. And I can see there's a positive
Sure.
x squared, so then I know up.
Okay.
Is that cool? Yeah, cool, awesome. Any other questions? What if I wanted more detail? What if I wanted to find where this side here touches this axis? How could I find that? Yeah.
Set x equal to 0.
Yeah, exactly. Just plug in the point x equals 0. So to find, and this is something we're going to do in our homework online and in practice, to find the y-intercept. And in our book, they call that the vertical intercept. Set x equal to 0 and find y. So you can go to the original, you can go to the big, let's see, where the hell is the original? Oh,
Right there.
is it
Over
right in
left.
front of me?
Left.
Oh, thank you. Yeah, thank you. Getting lost in the weeds here. So when I put in x equals 0, I get 10 out. So that means that this thing intersects the axis way up here at 10. Does this graph touch the x-axis? Does not. So there would not be any x-intercepts. There's no horizontal intercepts. If it pointed down or opened down, then definitely we could answer that question. All right, we'll try this. Let's try a slightly more interesting one. Little bit of a trick here. Okay, so how about I just grab one out of our section here? Ooh, there's a nice one. So here we've got h of t, sorry, equals negative 4t squared plus 6t minus 1. Let's go through this one together, because that minus 4, there's just a little subtlety that we want to be careful of. Yeah, definitely. So yeah, Mace is already seeing that it's opening, it opens downward, absolutely. So we have that image in our mind. We just don't know where the tip of it is, right? Where the maximum is. And that's what we're gonna find using our techniques. So this is like step 0 that I didn't put in. So if there's a number besides 1 in front, factor the leading coefficient. Leading coefficient is the one in front of the highest power term out. So I'm just going to do that out of the first 2 terms. So that seems weird, but watch how I'm going to do this. This is equal to, I'm going to pull the negative 4 out, make my parentheses, leave some space. I'm going to just write the minus 1 out here. And all I'm going to do is figure out what needs to be inside here so that I still have the same problem. So if I put a t squared, now I've got negative 4t squared, check. What do I need to put, what multiple of t here? So, yeah, so definitely, yeah, we need a 6. Yeah, I like that. Let's just do it because we know we need a 6. But I want that times this thing to be 6. So what needs to go underneath?
Negative 4.
Negative 4. So check it out. Here I multiplied this out and just wrote it underneath here. So now we've got negative 4t squared. And then when I take negative 4 times this, oh, there's a t. Negative 4 times this guy, and I need more space. I get the 6 back. See this, Mace? I see you, your furrowed brow, but when this minus 4 cancels with that, I get the 6t back.
Okay.
Does that sound right?
Yep. It's just placeholder.
Yeah, it's a placeholder. It's like we're doing some computations that are taking us to a good place. anything I can help with here. Make sure this makes sense. Now's a good time. There's lots of good times. Okay, so I still have to figure out what goes in here. I'm gonna actually simplify this because I don't like that nasty fraction. It's not nasty. It could be simplified a little bit to -3/2 t. And I'm just dividing out a 2 from the top to the bottom. Leave a little space and we still have the -1. So we're gonna play the same game. I'm gonna take half of this, so 1/2 of -3/2 equals -3/4. Just multiply the bottom by 2. And so I'm going to add on -3/4 squared. I'm just gonna write that here. But I also have to subtract that off. And subtract it off. So out here, I'm gonna put -3/4 quantity squared. Let me stop. Tell me how that looks.
Long, but like self-explanatory. It's just like a lot of steps.
Definitely, yeah. Just got to be careful. Mind our steps. Keep chill. Know this will end. Okay, so now there's one thing that I didn't do, which I just when I said and subtract it off. Notice that I actually didn't subtract off the right thing because there's a -4 out here. So that -4 times that actually gives me a different number than this one, right? Because that -4 still acts on this. And so let's put here multiplied by the leading coefficient. Almost forgot that. So in front here, I'm gonna put minus and then a -4. All I'm trying to do is keep this balanced so that if I start tossing stuff in here, I haven't changed things overall. So notice here, now we've got -4 of these and then +4 of them. Yeah, +4 of them. Let me stop because that's getting a little weird. I think we'll definitely do some practice on this. Yeah, okay, cool. All right, so let's simplify a little bit more. So now it's -4, and I can go immediately to the squared term. The thing I'm going to put inside here is just this number right here. That -3/4 goes right here. So when I take half that coefficient, before I square it, that's what's just gonna go right here. And then on the outside now, we've got minus, let's do all the crazy simplification here. So we've got -1, I'm gonna keep that there. What is this? 9/16 and a positive 9/16. Yeah, and you said that, like because you didn't say negative. So just beware that this is actually positive 9/16. So I've got -4, or minus, so that's +4 times that. Is that, yeah, cool, exactly. So this is going to be +4 times 9/16.
Minus 9/16?
Minus, did I get?
Or, no, it is plus.
No, it is plus, yeah.
Sorry.
It's all good. I got myself scared when you said that. I think we're all good. So let me stop. Check. And now all I gotta do is do this math out here, just add those fractions. So we got -4, t minus 3/4 squared. Let's see what we got here. Let's do a little scratch again. I've got -1 plus 36/16. Get a common denominator. So I'm gonna turn that into 16/16. got a positive 20/16 in the end, and if I simplify, that's 5/4. So not too bad. So this just becomes a plus 5/4 out here. And now we know where the vertex is. Where is the vertex? Yeah, Jack. Oh, sorry, was there a problem somewhere? Let me know now, that sounds good.
No, I just, would it be -3/2 instead of, or does that -3/4 you in front of stay in front of the t?
Oh shoot, yeah, wait. No, I think it's gonna be -3/4.
Okay.
It's totally cool. Yeah,
Okay.
and if you can prove that to yourself by foiling this out. Does that sound
no,
okay?
that's right, yeah,
It's
yeah.
okay, awesome. Whew. Good stuff. Thanks for caring. Anytime people call me on stuff, that's great. Let's check on shit. Let's be alert and do math together. Where's the vertex? What point? Remember, so you're comparing this to positive 3/4. So it's kind of the opposite of that. Yeah. So it's going to be positive 3/4. So the vertex, let's just write that out, is at positive 3/4, positive 5/4. So if that's 3/4, and that's 5/4, that's my vertex. Do I open up or down?
Oh, down, sorry.
It's good.
I have literally
It's
said
good.
it at
Hey,
the
you get it
start.
wrong. You just got to flip the answer, and you got the right answer.
I also said it at the start too.
You did. So this thing is going to go like this. And it has a maximum, so let's just make a note here, has a maximum of 5/4 at x equals 3/4. We're going to learn some really fast ways to do this with calculus. So it's good to kind of do it the old hard way, and then see a beautiful way to do it in a little bit. So I have one more question about this problem, and maybe you can help me. How do I find where that is happening, where it's touching the horizontal axis? Yeah, set y equal to 0. So to find these horizontal intercepts, we're going to set this thing equal to 0 and solve for x. And we can do that in a couple of places. So let's go back to the original problem quickly here. The original problem looked like that beast up there. So to find the horizontal or x-intercepts, set the equation equal to 0 and solve for t. So I guess they're t-intercepts here. So for t. So I'm going to take this and solve for t. So now, friends, there's two ways to proceed. I could solve that problem, or I could set this equal to 0 and solve and get it both ways. If I just gave you this and we hadn't talked about that, how would you solve for t here? What would you do? What could you do? Let's talk about all the ways we could find t.
We could use the quadratic formula.
So we're making this poor lady talk, and she's, yes, we could, yes, Lorelai, thank you, the quadratic formula. She has carried her load for us for today. So we could use the quadratic formula. That's always at your disposal. And the quadratic formula is that t equals, let's just give you the whole thing here. So if I have this, then then t equals negative b plus or minus square root b squared minus 4ac over 2a. So we can go down that route. Not a problem. We can absolutely do that. But we can also go to this canonical form and crank it out in just about the same amount of time. Let me show you that. So here, I'm just going to assume you could do that, plug in numbers and simplify. And if not, we'll talk about it when you arrive there. But here's the other route. So that's route 1. Quadratic formula. Route 2 is go to all this work we just did can pay off. So use the canonical form. And let's write it out. So we've got minus 4, and we're just going to set this thing equal to 0, minus 3/4 squared, plus 5/4 equals 0. And solve this. Why would I think this is easier? Because, well, 1, it's not the quadratic formula. And 2, it just falls apart naturally. Let's do this together. So move that 5/4 to the other side. In fact, this is how you actually prove this formula, by doing what we're doing here in general. So get that. Divide by negative 4. That turns into a positive 5/16. And then take the square root of both sides. Don't forget to put a plus or minus. So take plus or minus the square root. On this side, I'm going to get t minus 3/2 equals plus or minus that square root. And then add that over and we're done. I think that's maybe a little faster. That number there can be simplified a bit. But we've got it. We've got the 2 places where it crosses. Let's get a sense of where these are, just roughly. I want to simplify a little, just the math nerd in me wants to know. So that's 3/4 plus or minus square root of 5/4. Just take the square root of that 16. So that is 3 plus or minus root 5 over 4. Now the square root of 5 is more than 2. Right? It's more than the square root of 4. So I think it's like 2.17 or something, but it's 2-ish. So this number here is 2-ish. So that means if I'm just getting an estimate for my graph, I've got 3 plus 2-ish over 4, or 3 minus 2-ish over 4. And you can get these senses for things without doing any hardcore computations. So this is 5/4-ish, or 1/4-ish. Right? And so I come over here, and I got my plot, and wow, it actually kind of looks not too bad. So let's say that's probably 1/4, and then that's 5/4. Notice how they're each 2/4 away from the center. So I think I got it right. It's nice symmetry there. Mace has had it.
No.
Fuck this. Get
Don't
out of
worry.
here. Gotta leave. Oh, you can't.
Yes.
Any questions on this, my friends? Yes.
Why does it go from 3/2 to 3/4?
Hey, what a great question, because I miscopied.
Okay.
Thank you. Well, this is all screwed up. Oh my goodness. Thank you. Yeah. So that turns this to a 6. Oh boy, I was so excited over there. That looked so good. So that just fixes this. Oh, Mace is going to be sad he missed this. So that's 2-ish. 6 plus 2 is 8. So we've got 2-ish. And then here I've got 1-ish. Right? 6 minus 2 is 4. Or 1-ish. Wow. Okay. So So I guess this thing's a lot.
I
Wait
have
a
quick
minute.
question.
That doesn't look right.
Yeah, I
Yeah,
think
you
it's
just take off
key.
the square root. Like the squared, it just eliminates the squared. It would still be 3/4.
Would still be. Oh, I miscopied here.
Yeah.
But thank you for catching it, and thank you for helping me find my way back. Yes, because that doesn't look right at all. So hey Mace, if you watch this, just don't go back and don't watch this. Go back in time. So this should be 3/4, and then everything's the fun. Yes. So T is approximately 1/4 or 5/4. We'll go back to that. Thank you. Groovy. Let's do one last problem together, or maybe one for the first time. Let's do a little bit of a word problem. Put this stuff to use. So I've got a ball I'm throwing, and the height of the ball is given by h of x equals -112 x squared plus 6x plus 3. So that looks pretty weird. X is the horizontal distance. So we've got something like this going on. We're throwing the ball up. X is the distance that it's traveled horizontally, and h of x is how high it is at that time. That's a parabolic thing in general. So we have 3 questions here. And let me ask you let me get them up here for you. How high is the ball when it was thrown? Let's take a minute to just answer these questions. How high was the ball initially? This time right here, this distance right there. Question B is, what is the maximum height of the ball? And you're gonna wanna go to canonical form for that. And how far from the thrower does the ball strike the ground? So, way out here, how far does that thing go? That's our last question. Kind of left it just the perfect time, Mace. There's a little bit of confusion over here on my part. Everything's just as when you left.
What happened to the issues?
Yeah, well, the issues, yeah, it's a long story.
Alrighty, I'll watch it back.
No, don't.
Okay.
In fact, I say in the video,
Alright.
Mace, don't watch this.
Okay, cool.
Okay. Just confused. I'm gonna run to the restroom, so let's see if we can solve that. Be right back. Be careful with that -112.
You alright, big one?
I'm good.
It's funny because if you type that exact graph into Desmos, it's not what you get at all.
Which one?
The top graph above, unless it's not the one on your left hand side.
Oh, I'm not sure. Yeah, I think you're just doing a ball. Cause it's a guy throwing a ball.
But still, that
Yeah, it probably
should
is.
match the graph.
Yeah, yeah.
And this is what the graph looks like.
Oh, really?
Yeah, I don't know how. Oh wait, no, it does kind of. It's giant ass parabola that goes all the way up into fucking the maximum is 111.
Are you checking out a graph of it, Mace?
I am.
This is smart. That's
Is
always
this
smart.
cheating? Is this,
No, that's
okay.
smartness.
Cool.
No, that's a good thing to do, just to see what's up and,
For sure.
you know, get a sanity check as you go through it.
I always need one of those.
I need one pretty much 3 times a day.
Smart man doesn't know all the answers, but he knows where to find them.
Exactly. Yeah, that's wise words. Is this looking good? Are we getting that 72 in there? It's big. A little shocking.
It gets bigger.
It gets, yeah, it does. You're right.
Just a heads up.
Yeah, no. Speaking of sanity check, sanity warning, trigger warning.
I was a little confused when I first opened up the Desmos because I was zoomed in to like 5x5 in the square and it looked like just a straight linear line. I was like, that doesn't seem right. And then I zoomed out, I was like, oh.
Yeah, and actually that's a really interesting insight that no matter where you are on that graph, if you zoom in, it looks like a line. Yeah, that's actually calculus. Like that's a calculus thing. You're doing it already. Let me double check myself. I guess that's like a negative 36 squared. In actuality. Yeah.
There's that +3 too that's on the outside still, right?
Thank you. Appreciate
I was gonna
it.
say that.
Yeah, no, I appreciate all suggestions are welcome. Because they're probably very needed. Trying to think if this is like a pretty good throw. We'll find out. Gosh, this is like negative 108. Yeah, wow, cool. Imagine.
But it ends up being a positive.
Yeah.
Right, thank you. Yes, right. Yep. because that's, yeah.
I like how you and I both know this information from two different sources.
How do you know it, Mace?
Because I'm looking at the graph. I'm looking at Desmos.
Okay, cool. Awesome. That turned out pretty in the end. Not bad. Is this looking good? Are we in agreement? Does anybody want help getting here? No? Good. Cool. So, awesome. Now we can answer our questions. How high is the ball initially? We don't even need this.
You can just look at the constant.
Yeah. So how high was it, Mace?
It was 3.
3, and I guess feet.
I didn't get a unit of measure, but
Yeah.
I'm
yeah.
assuming. Well, if it's 3 feet, this man can throw it 110 feet in the air.
That's what I was trying to figure out. If this, yes, and this is in feet.
Guy's got a cannon.
That seemed pretty crazy. Yeah, that's pretty freaking tall. Yeah. Okay, cool. So the initial one here is basically just what is h at 0, and that is 3. That's probably easiest from up there. Otherwise, here you got to go back and do a bunch of work. What is the max height? So where's the vertex of this thing? Where's the
36?
36, comma
111.
111. Beautiful. So the vertex, and this is going to be not to scale. That's pretty bad scale. This is a crazy. I guess it's just basically throwing it almost straight up,
Rocket
right? Just
propelled.
winging it at the sun. And then, okay, so we got that, and then how far does the ball travel? I've got to figure out where it hits the h-axis. So for this one here, we're going to set the equation equal to 0. Just go with this one and solve. So let's do it, and I've got a feeling Mace has got an approximation for us via graph.
I do.
So beautiful. So we'll get a sanity check there.
For sure.
So we're going to get -1/12 x minus 36 squared plus 111 equals 0. Gosh, I think I'm just going to multiply through by -12 to clear that out. So that's going to be x minus 36 squared, and then 111 times 12. I'll see, shit, I'll just do it. That's not too bad. So that is minus 1332 equals 0. And then move that to the other side. Take the square root. Now here I'm probably going to need a friend to help me. So I'm going to get plus or minus square root of 1332. Could someone help me out with that, please? That'd be lovely. Mr. Technology, you can't take the square root for me?
Oh, I can.
Okay.
I just, it wasn't a show of skill. So
Okay.
72.497.
Thank you so much.
Yeah, no, I just figured it wasn't a. Yeah.
What did you get, May?
72.497.
Thank you.
Ish.
Yeah. So let's just go 5,
Yeah.
right? Yeah, we're not doing any surgery here, and that's a plus or a minus. So I'm a little.
No, that's just what the intercept is. It'd be close.
Oh wait, so okay, got it. Okay, so what is just the square root?
Oh, sorry.
That's okay, yeah, because that wasn't gonna work out.
I think it's like 11.5 something.
11.5 something sounds pretty good. We'll say 0.5. Yeah.
11.54.
Beautiful, thank you. 11 and a half is splendid. I'm not sure where that 70 came from. We'll take a look at that in a minute.
That is one of the intercepts.
I don't think so. Because I get that. And so, actually, that seems totally fucked up.
I got 36.5 for the
You got what?
36.5
36.5 as the final answer?
for the square root.
Oh, for the square root. Yeah, can we check that square root out again? Because one of these should be a negative number, looking at the picture, and one's probably closer to what Mace was saying.
Yeah, like the
Yeah.
farthest distance that it
Yeah, it's
traveled,
30
or like on the
36
x-axis,
point
like the
five.
last x-intercept, or before it hits basically ground, would
Yeah.
be 72.4.
That sounds right. It
The
is a-
first x-intercept behind where you threw it would be negative. I'm assuming.
There we go. Hannah, how did you get that?
I must just put in the calculator wrong.
Okay, cool. So it's okay, good. It's all right.
Shit happens.
I love the discussions we're having. So what is the actual square root? What?
36.5.
36.5. Wow, ridiculously close to that. So then, yeah, that looks to me like some 70 action. So x is equal to -1/2, which is right behind. It would, if it, just like if this had started back in time, it would have been that many feet behind the person, or 72.5, and I think that's what you said, Mace.
That is correct.
Cool. And so this is the answer we go with because we're looking for the future. All right, does this sound okay?
Sounds wonderful.
Oh, beautiful.
I'm still getting the same.
I'm gonna come take a look. We'll come take a
Okay.
look. So let's take the rest of, we only have 15 minutes. I don't wanna just keep rambling at you. I wanna give you time to work on this homework. I also opened 1-6. You can probably do some of that. What I think would be cool is if you could try starting on it and then we'll talk on Monday. Does this sound okay?
Yeah.
Yeah? And if you need more time on anything ever, let me know, and that'll happen. So I'm gonna come take a look at what's going on with Hannah's square root. Okay.
I don't know.
Oh, because it's not a 0.2. It's
Oh.
it's just
I was gonna say, I was like, man,
1,332.
I keep kind of missing the calculator. This is
Yeah,
okay.
yeah.
Okay, so okay. Go
1 through, yeah, there you go. You
There's
should,
six.
yeah, there you go. Awesome. It's like I know you know how to take your
I know,
square
that's why I was
roots.
like confused every single calculator.
You got it.
Sweet. Okay, that makes sense. Thank you.
How you doing, Caroline? Everything good? You want to talk about? You're all good?
Yeah.
Awesome.
Thank you.
Awesome. How are you doing here? I have a feeling you're doing good. Yeah. You're doing good. You're cranking it.
Yeah.
Let me know if you need. Cool. Thank you. You're so welcome. Jack, you're just rocking it.
This.
Which one? The.
There's
Oh,
this.
huh. It looks a little off. It kind of, is the answer you've given it not working?
No, it didn't work, but I think it's because I just
Hmm.
tried to make it work
Okay.
and it wasn't actually
Got
the
it.
right answer.
Got it. Yes, sir.
It's so strange.
Wow, so what's good, what's it?
Because you go back, and like I get this feeling, right? It makes sense in my brain. This sense also makes sense in my brain. Then I get to this, and then this time for what happens.
Okay, you wanna talk about it?
Yeah, so
Awesome.
like This I can kind of rationalize in my head because
Yeah, how'd you do it?
plug in one over
Mhm.
here, and then wait, no, you just that, correct?
So that's, yeah, so g of 1 is 5, and then you put 5 in over here, and you get out, turns out you get out 5. So this one says, go to the F graph, put in 2 first, what's the output?
4.
And then feed that into the G.
Okay.
Does that make
Gotcha.
sense?
Yes.
Yep.
Yes.
Now you're a master of it.